This is Dr. Sajja Suneel from Data Science Department. Today we are going to discuss about Internet of Things. What Internet of Things are. In this Internet of Things, what we are going to discuss today. In Internet of Things, principles of Internet of Things, we are going to discuss about some particular module called controlling hardware and sensors. And in this module, today's topic was controlling servo motors and speed control of DC motors. These are the two topics which I am going to discuss with you today. Have a look, guys. First, before entering into these particular topics, I just want to give you a small brief about what Internet of Things was, how Internet of Things was playing a major role in any kind of industry, right? Our particular course has been designed in such a way that students should be able to know about what kind of IoT levels are existed, what kind of IoT development has been emerged, what was the latest trends which are utilized by IoT industry. Along with that, in every aspect, these IoT are playing a best role and crucial role nowadays. And have a look, guys, what this particular course and what exactly this is particularly designed for, and have a look. We are going to discuss about a particular topic called controlling hardware and sensors. In this controlling and hardware and sensors, in my previous classes, I have narrated you about controlling hardware introduction, along with that connecting an LED hardware device, how the things are going to be done. In my previous video, I have narrated with you. And after that, connecting a buzzer, and after that, switching high power devices with transistors, that was also discussed. And after that, I have discussed about controlling AC power devices using relay. These are the things which I discussed with you in the previous class. What relay was? A relay is a magnetic switch, whereas a transistor was a thing which is going to place between to connect and high power. We need to use low power devices. In between, a switch has to be established, which makes us to connect with the high power devices. Transistor is a switch, whereas relay is a electromagnetic switch, which is going to be utilized where we are having two different things. And by using those two different things, once if that particular thing was activated, automatically the magnet is going to attract the things. With that, it is going to switch on. So for that purpose only, it was called as electromagnetic switch relay. And coming to today's topic, controlling servo motor and speed control of DC motor. These are the two topics which comes under controlling hardware. And after successful completion of these, we are going to discuss about multiple sensors such as unipolar, bipolar, stepper motor sensors, light sensors, temperature sensors, thermistors, voltage sensors, and which is used for ADC and DAC, where we are going to know about it. And after that, we are knowing about the temperature and humidity sensors, which is the best example, DHT11. And after that, motion detection sensors, wireless Bluetooth sensors. These are the multiple sensors which are existed. Along with these level sensors, USB sensors, embedded sensors, distance measurement with ultrasound sensors are also presented in this particular module. Among all these sensors which we are going to furtherly discuss in the coming classes, in today's class, we are purely focusing on two major topics. First one is controlling servo motor. Controlling servo motor. This was the topic which we are going to discuss. And the second one is speed control. Speed control of DC motor. Speed control of DC motor. These are the two topics which I am going to discuss in detail with you And before knowing about this particular topic, from this current module, what we are going to get, I just want to give you a particular narration. From these two, the main objective of this particular module was data acquisition and monitoring. Why data acquisition is required? Why data monitoring is required? There are n number of hardware devices and number of sensors which are placed in a IoT system. From these hardwares and sensors, we are extracting a huge data where our data acquisition, which means we are acquiring the data, that particular data, by based on that particular data, after performing the analysis on it, we are giving a decision making on that particular data. For that purpose, data acquisition and monitoring will plays a major role. Gathering information was the first part in this particular thing, where the sensors will place a major role. Why? Because sensors are the things which collects the information, which collects the data, but about the environment or about the system by itself. Truly, take a real-time example. We are having a smart gadget with us. In that, there was a sensor which is going to detect the temperature and letting us to know about what kind of temperature was existed outside the house or inside the house. The sensor was the thing which is sensing the information about the particular environment, where the data can be anything. Either it can be on temperature, it can be on pressures, or it can be on light levels, or it can be on motion levels, or it can be on chemical composition. Each one of the particular thing can be treated as an individual of that particular IoT system. For suppose, take an example. I just want to know the pressure which is applied on that particular water. So water is going to fall down on some particular thing. Through that, we are generating some energy. And what was the pressure of that water which is going to be released towards it? And about temperature, what levels of temperature has been recorded in day-to-day life? And coming to the light levels, what kind of light level is required at the time of studying, at the time of watching televisions, or at the time of sleeping? There are certain levels which are going to be very useful. And coming to motion, how much motion is applied? For suppose, even I am discussing, even I am narrating some information to you, there is a motion which is happening in my style or in my gesture, whatever you can treat it as. And along with that, there is some chemical compositions. There are some chemical compositions which are happening. Even in air also, there is some gas which is mixed. We are unable to detect whether it is harmful or whether it is unharmful. That we too don't know. There is some extreme level which is going to cause effect to humans. For that purpose, we are using these IoT systems. With the help of sensors or with the help of hardwares, we are going to detect it and we are going to update the things. And as I told you, in data acquisition and monitoring, the first impactant factor was gathering information, which is taken care by our sensors. And coming to the second one, how to track the data and how to analyze the data. Continuously, we are gathering the data by using with the help of sensors. How that particular data is going to be tracked and how continuously we are monitoring the sensor data or not. For suppose, if I am writing something by using this particular calibrate, right? If I am writing for something on the screen, see here, I am writing sensor. There was a force and there was a thing which is applied. This was the data, and by using this, it has detected something, and the same information has been shown to you on the screen also. Continuously monitoring sensor data, where we can track the changes of over time and identify the trends. For suppose, I will let you know a small example. Temperature sensor. We are knowing about temperature sensor. Let's read for some time. We are knowing about temperature sensor. What this temperature sensor will do? We are placing that particular temperature sensor in a kind of IoT system. what's the job of that particular temperature sensor was, the sensor is going to sense the data and continuously it is upfeeding the data to the concerned console. Automatically the actuator was the one which is going to show you the action depends on the sensor data. So continuous tracking and continuous analysis is required. With that only we are able to update. So for so and so time this was the temperature, and after so and so time this was the temperature. After 2 or 3 hours there will be a rainfall. Like that we are going to calculate the climatical conditions also by using our IoT advancement. This is how the things are happening. And coming to the next factor, next objective was system automation and control. The first one, data acquisition, and the second one was system automation. And in this system automation and control, we're having futures like influencing the environment. How we are influencing the environment by taking certain hardware components called as actuators, which are going to be controlled by us for physically changing the environment. Example, take an example. There was a switch. There was a light in my concern room. I need to switch on that particular, turning on the lights. Turn on the lights, which is the best example, influencing the environment. And opening valves, which will be in banks, and starting motors, even our water motor, or else the level of the water is very low. Automatically it should sense it and it will pass an information through actuator to the concerned motor, so that automatically the motor is going to get started. By using this sensor data as an input, we can automate all these particular action based on the predefined condition. Physically you need to switch on the light. These are the tasks which was done by physically without the help of sensors. Switch on the light. And we need to open walls physically. Like lockers. You can take the best example as lockers, valves. And start motor. Starting motor. These are the 3 examples which are taken, which are going to done by us regularly, which is without the help of IoT sector physically. For suppose if you use the sensor data as an input, sensor is sensing information, some motion sensor. If I place motion sensor, automatically it will sense my motion and informs the switch to automatically switch on, so that turning on lights was done. So it was automated. Got it? And coming to walls, there was a sensor which is going to be detected our face or biometric by based on your fingerprint. With that, automatically opening valves was also automated with the help of these sensors. And coming to the next one, starting motor. Take a best example, your water tanker. Your water tanker in home. And in this was comes under home automation. Home automation. Right? In the home automation, water tanker level. For suppose the water was less than 20%. At the time of configuration, I do this configuration. Automatically, it will sense, the sensor is going to sense it and pass information to actuator. Automatically, actuator is the one who is passing information to motor to switch on automatically. So, motor is going to fill the water tank. When it reaches to certain level, 95 or 96, depends on the configuration, 95 to 100, automatically it is going to sense and it will pass an information through actuator to the concerned board. Automatically it is going to shut down. So no need of human physical intervention here. So all the 3 things are going to be converted into automation successfully by based on our sensor data. That is what how we are influencing the environment by using our IoT devices. This is how the things are going to be happen. And coming to the next factor, which is optimizing performance. How this optimizing performance will be done. Have a look here. And in this optimizing sensor, controlling systems by using our sensor data, and also actuators are going to be set it out in a particular time. And by using this optimization of performance like temperature, efficiency, and resource usages, as well as many things which are going to be done with the help of this optimizing performance by based on our sensor data. And the next factor is to improve our experience, right? In many of the cases, controlling hardware creates a more convenient and more most user-friendly experience to us. For example, take a thermostat which is going to automatically adjust by itself. We depend on the heating-based sensor reading of the temperature. That was the thermostat thing. For suppose, if the air condition system was automated with the help of this sensor. By constantly observing the sensors, the room temperature was set it to 21. If it was high, automatically the air conditioning system is going to take care to maintain the room temperature to 21. If it is very cold outside, even though it was a -1 outside, the same air conditioning system is going to produce some heat and maintain the room temperature level to 21 only. This is how the automation things has to be done with the help of our IoT system. This is how the things will be done. With this, I want to tell you what exactly the things which we are going to achieve after successful completion of this particular module was. We are going to improve the efficiency factor. That was the first one, where automatic tasks and optimizing processes are going to be done with the specific resources. And coming to the next one, we are going to improve the safety, where the control systems are going to prevent major accidents or small accidents which are going to occur by taking a corrective actions based on our sensor readings. And coming to the next one, enhanced decision making by based on the sensor data. By analyzing that particular data, we are going to predict and we are going to take a particular decision making by based on the insights, valuable insights which are going to be provided for us with the help of that particular sensor. And the last one is greater convenience and comfort, where it is going to be automated systems which is going to create a more effectively and more user friendly environment for us. This is how the things are going to be done in our particular module called controlling hardware and sensors. And now we will enter into our particular topic, which is called as controlling servo motor. What this controlling servo motor was, as I told you in our principles of Internet of Things, servo motor was playing a pivotal role in the applications which we require, which we needed for our angular positioning. How our servo motors are going to be used and how those are going to be controlled by a particular IoT system. How the things are. First, we need to understand what exactly these servo motors are. Servo motors are unlike DC motors. Servo motors are going to offer you a precise control over their shaft rotation angle. And here this is going to achieve a combination of DC motor as well as a gear mechanism, where the position feedback control loop by based on position feedback control loop. Typically, we can call this servo motor as a range of rotation, which is controllable range of rotation. Often we can state it as 180 degrees, but it also can be less when it is compared. This is how the servo motor was. How we are going to control these servo motors with microcontrollers. What exactly microcontrollers? We need to know what exactly microcontrollers are. These are the things which are going to send some control signals to the servo motor in form of pulse width. In this particular format, it is going to send. How this pulse width modulation series is going to be. Uh, in general, I'll let you know for a better understanding by taking a small real-time example. Most of you guys have seen a pulse wave, how the heartbeat was rising and how it was slow and how it was ringing. Psychics, some kind of pulse wave signals which you observed on what those machines which are used in hospitals to see our ECG report. In that there was a pulse information. For suppose our heartbeat goes high, automatically the pulse is going to be shown to you in that particular ECG format. In the same scenario, here also control signals which are going to pass the information in form of PWM, which is a pulse width modulation wave. PWM, pulse width modulation wave. Coming to the next factor, the width of the pulse, which is very fixed time cycle of this servo shaft. And here there is no longer instructions which are going to be passed to the motor, only because in a single direction, a clockwise direction is going to be function in a single direction, only one direction, no multiple directions, right? This is clockwise and this is counterclockwise. Got it? Here, whenever you got a shorter pulse, which tells you to rotate in other direction. For suppose you got an instruction from the motor with longer pulse width, automatically you need to go with clockwise. If you got a short pulse, you need to go with auto counterclockwise. Got it, guys? If you get a longer pulse width, then clockwise. If you get a shorter pulse width, you need to go with counterclockwise, which is like this. Got it? This is how the things are going to be happen while controlling these particular servo motors with the help of microcontrollers. How we are going to use these servo motors in our IT projects, such as there are n number of applications where exactly these control servo motors are going to be used in our industries, such as the first one is robotics. The servo motors are the essential components in building robots. Why these are essential components? Because for allowing the grippers, arms, wheels, which are adjusted through that particular robot, that can be done with the help of these particular servo motors only. And the next one is animatronics. Animatronics was the things, animatronics, which means animations, animation characters or animation objects, which is going to define a specific movements which lies on these particular service motors only for precise positioning. For precise positioning purpose in animatronics, this is going to be used. And coming to the next factor, which is control surfaces. How to control surfaces? For suppose there was an antenna which is placed over in our top of the house. We need to go there and we need to change the position of the antenna. This was the task which was done in my child days. But now by using this servo motor, I am capable of changing the direction of the antenna, or else I am capable by changing my lens, camera lens, or I am capable for changing the solar panel automatically towards the sunlight. Morning the sun will be rise from east, so the solar panel has to be focused towards the sun lights which are going to be projected to the panel. Evening again the panels has to be turned automatically by basing on that particular sun set. Got it? This is how controlling surface factor with the help of servo motor, how the things are going to be done automated. That was the task. And the last one is interactive display. What interactive display was? Interactive display was the thing with the help of these servo motors we are going to create a dynamical displays where which are going to be moved, which are going to be changed from moving parts or moving lights, we can say. Those are the interactive displays. With the help of these servo motors only, all these projects are going to be initiated, such as this first one robotics, and second one animatronics, third one control surfaces, Fourth one, interactive displays. These are the things which we are doing. And what are the different things are required for connecting and controlling a servo motor? First, what are the materials which we require for performing this particular task? A breadboard is required, a jumper wire is required, servo motor is required, and microcontroller board, which is Arduino Uno board. And coming to the connection, these servo motors typically will have three different kinds of wires. What those wires are? Usually red will be used, black will be used, and yellow or orange. Anything which is convenient to you, you can use it. Red is automatically used for power, and black is automatically used for ground and control, which is usually yellow or orange. Connect the power and ground wires to the corresponding power cable and ground rails on microcontroller, and connect the control wire PWM pulse width modulation wave capable pin was connected to the microcontroller. This is how the connection has to be done. And coming to the third part, which is microcontroller code, where we are having n number of libraries like Arduino Servo library, which is useful for this particular controlling of this particular motors, where the code is going to define you how the servo object was and how the pins are attached and how the functions are being written, such as the functions called right function, set positioning function. For a desired angle, these particular things has to be set out. For that purpose only, we are configuring this right function and set function for specifying a desired angle in degrees based on the sensor data or based on the user command. For suppose user command means if I am the administrator, by based on my direction, the servo motor has to act and pass the commands to the concerned IoT device. With this, these are the steps for controlling and connecting this particular servo motor. Excuse me. And coming to the next one, what are the different kinds of learning resources which you are getting for controlling this particular servo motor? Have a look here. There are a number of tutorials which are available, such as based on a particular topic called controlling servo motors with Arduino, or else servo motor basics for beginners. These are the resources which are going to give you guidance step by step, and in form of coding or in form of controlling servo motors. And many of the starter kits nowadays are learning through their hands-on experience. Hands-on learning concepts has been initialized, and for the starter kits, microcontrollers like Arduino kits, which includes servo motor in it, and also some components which are required for basic control experiments. By incorporating this controlling servo motors into your IoT projects, you guys, I can promise you guys that you are going to achieve and you are going to interact with your particular system, such as opening doors, to create for doing more creative and functional applications like opening doors. Right? With this, I can conclude by stating this word. If you learn this particular controlling a servo motor with the help of these particular learning resources, as well as the things which I shared with you guys, you are going to create wonders in any kind of IoT systems, and you make more interactive about those particular devices. Such as, I will tell you a small example. Whenever you guys are regularly going to malls, right? Whenever we are entering into a mall, automatically a sensor will sense us. Automatically it will pass information to the actuator, which is your servo motor. With that, the servo motor starts functioning by opening the doors automatically. No person is opening physically, right? It is going to sense a motion detection in front of that particular door. Automatically it is opening, and after passing of that particular person, automatically the doors are going to get closed. Like that, we are configured. We are the one behind the theme. Got it, guys? This is how we are controlling the servo motor. And coming to the next factor, which is speed control and of DC motor. How this DC motor and how the speed control has been done in our principles of IoT. This particular task is going to design with multiple applications, and there are different kinds of methods. Among those different kinds of the methods, the first one is pulse width modulation, PWM. This was the best common and versatile method for DC motor for controlling the speed in IoT. And also it is going to work with duty cycle by based on this PWM only. What PWM was? Pulse width modulation signal, which is going to be sent to motor driver circuit as I specified you previously. And here the every duty cycle is going to get some particular time, some percentage of time signal, which is going to be fixed highly. And what high duty signal was, what low duty signal was, nothing. The small difference was high duty signal was longer high time and low duty signal was shorter high time, where longer high time is going to provide you average voltage to the motor which is resisting to the high speed, where lower duty cycle was the thing which translate lower average voltage and slow motion speed. If you got high speed, automatically a voltage is applied and the fan will rotate in a swing mode. And whenever, not swing mode, fast mode, whenever you pass a low power, automatically it will rotate in a slower motor speed. This is how the things are going to be happen. With the help of microcontrollers, PWFM functionality is going to specify you with these things. And the second one, voltage controller. This was the second method which is directed by controlling the speed control by in our motor. And this method is going to directly adjust the voltage which is going to supply to the monitor or which is going to be influenced by its speed. Whereas there are n number of simpler concepts compared to the PWM, which are voltage controlling. If we supply a high voltage, which is going to automatically increase the speed of the motor. But if it exceeded, it also can damage the motor also, right? The motor is capable up to, for suppose take an example, the motor is capable up to 10 volts. If I provide 1 volt, the motor will rotate very soon. 2 volts, it will increase. 3 volts, it will increase. 4 volts, it will increase. 5 volts, if it reaches to 10 volts, it will use the best performance. Why? Because it's the maximum. If I give you 12 volts, automatically that component is going to be damaged. So we must be careful, guys. And coming to the second factor, low voltage, which is going to slow down the motor, where we are reducing the torque power, which is rotational force. Torque is nothing but a rotational force. And in this IoT application, voltage control might be used for specific motor driver circuits and it can be used for the purpose. And coming to the third factor, which is by using motor driver circuits. What these motor driver circuits are? Microcontrollers are the things which are going to provide, or often it cannot also provide high current whenever that particular device requires. Motor driver circuits are at that time, these can be acted as an intermediators between those two, where it is going to take the low power signal from the microcontroller and translate it to the high power signal to the driving of the motor. Whereas some circuits are also there which are included in direction control as well as over current protection by making up the functionalities. These are the things which has to be kept in mind whenever we want to control the speed of the DC motor. There are such applications where DC motor speed is going to be controlled in our IoT system, such as robotics. In robots, for a precise control or by improving the motor speed, it is very crucial for robots to move at desired speed and perform specific actions in it. If kept in a high mode, the robot is going very fast, so that it can be damaged. There are chances. So we need to check it out. And drones and RC vehicles. Speed control is very, very essential in these particular devices such as drones or RC vehicles, which is going to done with the help of this speed control is essential at the time of maneuvering and maintaining the applications stability, especially stability purpose. And coming to the smart fans and appliances, which are used in our home automation. IoT enabled fans, IoT enabled pump are going to improve the speed, and by based on the temperature readings are user commands. And the last one is conveying belts. This is the important thing, which factor where it is allowing us for handling the material and for processing the automation in our IoT driven manufacturing. These are the different kinds of applications. How we are going to choose a specific right method among all these hardware components. PW1, which offers a good efficiency and good flexibility compared to the other things in our IoT applications. And also, voltage control might be the simpler and specific setup, but limitations in the efficiency control. And the choice of the method depends on specific mode which is going to enroll in your project. And coming to the last factor, which is learning resources. By seeing these learning resources, you guys are capable of knowing the speed control of DC motor. With this particular topic called DC motor, speed control of Arduino, and PWM control of this particular thing. And many of the starter kits are controlling these microcontrollers, which includes the DC motor driven things. I'll conclude my lectures for today by stating a small word. By understanding these methods, controlling the motor with DC power, controlling the AC power, and controlling the microcontroller, with these particular steps, you guys are more effectively know about how to control the speed of DC motor and how it can be utilized in your future IoT projects, which makes you enable a wider range of functionalities and interactions with the physical world. This is how the things are, and I am signing off today. Thank you very much. Have a good day.
Like, share and subscribe. Hit the bell icon for more updates.